Hello everyone, my name is Aryan Bhandari and this is course by DoCoNation. In previous session, we learned about object-oriented programming. We learned about classes and objects in Java. And in this session, we'll learn about inheritance and types of polymorphism in Java. So what is inheritance? So even generally, we tell that sometimes we say that you have inherited some properties from your parents, like your nose or your eyes is similar to that of your parent, right? So that means we have inherited some properties from our parents. Similarly, in Java, when a class inherits some properties from a class, that class is known as child class or derived class, and the class from which the properties is being derived is known as the parent class or the base class. Okay, so let's code it. So I'm writing a let's say parent class. Okay, parent. Now I can give it a property. Let's just say some property. Okay, and I'm gonna create a child class also. And okay, so now this is just a class. Okay, which has a name of child, and this is just a class which has a name of parent. These are not related to each other yet. But when we use extends keyword, so this is extends keyword is usually used for inheritance. Okay, so if I use extends keyword and I write parent, so now this property is available to this class also. Okay, because this class child class extends parent class. Okay, so all the properties inside the parents, let it be the fields or the methods inside parent, will be available to the child class. Okay, now let's just see. Let me create a method in child class. Let's just say public void show, and I'm gonna print the property, okay, which is coming from my parent class. Okay, so I'm gonna create an object of child class. So class name and then object name equals new keyword and then child. Now I can use this object to call the method. So I'm gonna call show method. Okay, and I'm gonna save it and run it. So as you can see, it printed 10. Okay, so this is coming from the parent class. So now let's talk about what are constructors. Okay, so if you write a method which is of same name of the parent, okay, like public and parent, so this has the same name which our class has. Okay, so if you write the same name which class has, that means that is a constructor. So this is a constructor. You can either write public or don't write, doesn't matter. It means the same. Okay, so it's a method. Yeah. So I can write something over here. Let's just say from parent. Okay, and let me create a constructor for child class also. So how will we create constructor for child class? We have to give the same name to the method. Okay, so this is the constructor of child class, and let me print from child. Okay, now when this constructor is called, whenever we create an object of a class, so the constructor will be automatically called. Okay, whenever we create an object, so in this we are creating an object, right? So I'm not gonna call this method, okay, because this is a constructor. So I'm calling this show method and I'm not calling anything. Let me just run it and show you. So it's printing from parent and from child. Okay, why? Because I have created an object of the child class. Okay, so as soon as I create the object of child class, the compiler will see whether the child has a parent or not. Okay, if the child has a parent, then I'm gonna print its parent class's constructor first. Okay, and then I'm gonna print my constructor. Okay, so it printed parent class's constructor from parent, right? And then it printed its own constructor from child, and then it's printed this method. Okay, that method because I have called it. And if I just remove this, I'm not extending the parent class, so this property won't be valid over here. Let me comment that. And now if I run, so if I run it now, it's gonna say from child, because as soon as I create an object of a class, it's constructor gonna run. So without this also, it calls a constructor. If you do not mention any constructor, any user defined constructor, it's gonna call default constructor, which is given by Java itself, okay, which is empty. So now if I remove this constructor, okay, and I run, so it is calling the parent constructor, because as soon as I create the child object, it's gonna check whether its parent has the constructor or not. So if it has, then it's gonna run that constructor first, and then it's gonna come to the class. So this is about constructors. Any doubt, guys? Let's move on to what is method overloading. Okay, so this is a constructor. Okay, now, and this is a method, right? This show is a method. Let me create one more method, say public void show, and I'm gonna write some arguments inside it. Okay, and I'm gonna print from child and add that. Now, when will be this method called? Okay, so when we pass some, so if I run it now, let me just comment this. So I'm calling the show function, right? And I'm not passing any arguments with this. So if I run it, it's gonna call this one, right? This property wala. Now, if I pass any argument, let's say I'm passing 10, and this 10 is an integer. So over here, I have written another function which catches that argument. Okay. So now what's going to happen if I run it? So it's going to run this method, right? Because I've given the argument, which is more relatable to this method. So if I write the same method name but with different arguments and return type, that is known as method overloading. Okay, so this is known as method overloading, and this is referred to as a compile time polymorphism. So this is compile time polymorphism, okay? Method overloading. It is also known as early binding. So this was about basics of inheritance. Now let's take a dive further, and I'm gonna show you with another example. Okay, so let me just comment all of these. So let's just create a class robot. Okay, inside this, what properties of robot I can write? So I can have a name, right? A name. Okay, and what else it can have? It can have a chip number, right? Chip number, and we can also give a like some steps it would have walked. Okay, so these are some fields. Okay, now I'm gonna write a method. Let's just say our robot can walk, right? So I'm gonna write a method public void walk. So this is a method, right? And I'm gonna say that uh, robot is walking. Okay, and I'm gonna create one more function. So I'm overloading this, right? I'm taking some steps, and I'm printing robot walked. So some steps, and what will be that? The steps which I'll get. Okay, so I'm overloading this walk method. Now let me just create an object of robot class. So class name, its object name, new keyword. Okay, now I can call my walk function. So if I simply call my walk function, not wait, walk, and run it, so it's gonna say the robot is walking. But if I pass some steps, okay, some argument which is there in integer, so it's gonna run the other method. Okay, so robot walked 5 steps. Okay, if let's just say I'm gonna create a constructor for my robot class also. So simply write the class name as the method name. Okay, and then I'll just say my robot is created. Okay, so whenever I make an object, this will be obviously called because constructor will run automatically. If I run it, so robot is created and then this, because I've called this method, so this will run. Fine. Now I'm gonna overload the constructor also. Okay, so this is known as constructor overloading, just same as method overloading. Okay, so robot, and over here what I need some name and chip number and some steps. Okay, or let's just exclude steps for now. Right, and I want to print this name, and let me just write it properly. Name, and we'll have the name over here. Similarly, we will have a chip number. Okay, so our chip number which we passed over here, that we can write. Okay, so I have created these fields, but these fields are not initialized, right? So what I'm gonna do, I'm gonna initialize those fields also. So when will this constructor will run? Can anyone tell when will this constructor will run? I have given it some arguments. So if I give some arguments to a method, and then when I call a method, and if I pass some arguments, it's gonna run that method. Similarly, with the constructor, if I pass some value, like let's just say Aryan, and I need to pass a chip number also, right? So I'll just pass it 2019. Okay, now this will call this constructor, the constructor with these arguments, right? Because I'm passing a string and an integer, and the constructor which is taking that is this constructor. Okay, so string name and integer chip number, right? So now when I got this field from the user, I'm gonna store it in this. So I'm gonna say name is equals to name. Okay, so you will be telling this doesn't make sense. Okay, I'll explain. Chip number is equals to chip number. So we know that the chip number or the name I'm passing must be filled inside this name. Okay, but the compiler or the Java JDK doesn't know this. Okay, it's getting confused. It's giving me a warning. Okay, so qualify left hand side, so it's not able to understand which name are you talking about. It, what it's understanding? It's understanding that this name equals to this name only. It's getting confused, right? So nothing will take effect. So for that I have to use this keyword. Okay, so this dot name, that means this class has a field known as name, use that. Okay, similarly with this dot chip number. Okay, so now it understands and the warning has gone, right? So I have successfully renamed it, I mean stored the value which user has given. Okay, now if I run it, okay, so now the constructor is this one, right? So name is Aryan and chip number is 2019. Okay, and this as I already called it. Fine. So this was about constructor overloading. Okay, so this keyword has many more uses, like now I have used this name, right? The field I have used. Now what if I don't call this over here, and I let me just do this thing. Okay, can we call a method use? Can we call the same class method using this keyword? So walk, and I'm gonna pass it some. Let's just say 60. Okay, and if I run it, as you can see, this automatically called this method. Okay, I did not call over here because this keyword can call the method name method name or the fields of the same class. Okay, and if you simply write this like this, it's gonna call the constructor of this class. Okay, so this will call constructor of the same class. Okay, similarly this will call the method field name, and this will call the method name. And there is a rule that whenever you write this keyword, or you wanna using this keyword, you wanna call the constructor of the same class, that should be written before anything else. Okay, before any of these we should write this. Okay, now if I run it, so my this constructor, okay, should also be called. Okay, robot is created, so my this constructor is also called because I used this. Fine, so this keyword is always used to call method, constructor or field name of the same class. Now let me create another class. Okay, so I'll tell that this is a fighter class which will extend the robot class. Okay, so this robot is special and this is a fighter robot. Okay, and this robot, obviously all the robots are going to have the similar properties, right? So any robot can walk and any robot will have a name or a chip number, right? So similarly, I'm creating another robot which is named as fighter, and it extends robot. So robot is the parent class and fighter is our child class. Okay, so fighter is gonna have all the properties of robot class. Okay, so fighter is special, so it will have another function which is known as that it can let's say it can punch. Okay, so I'm gonna print that fighter robot punches. Okay, now if I just let me create a object of this fighter robot class. So let me come in this and write fighter f1 equals new fighter. Okay, so what will happen if I call initialize, let me run it. So it's telling robot is created. Why? Because fighter is a child class. So whenever you create an object of a child class, it first checks whether parent has a constructor or not. If a parent has a constructor, run that constructor first and then come to the class. Okay, so robot is created. Obviously, if I create a fighter also, that is also a robot. So robot is created, right? So that makes sense. Now using this, I can call my punch function also. So robot is created and fighter robot punches. So spelling is wrong, right? Fine. Now if in this child class, if I write this void function public void walk. Okay, so this same function is also there in my parent class. So now what it will call? Okay, let me just give it like fighter robot is walking, and this is like simply robot is walking. Okay, so but this has the same method and this also has the same method. So if I create an object of a fighter class, okay, and if I call, let me call walk function. So which walk function will it call? Let me run it. So it called its function. Okay, so whenever you call a function, so it is first gonna check its inside its class. Okay, so whether there is a function or not in this class. So there is a walk function. I am gonna call this first, and then I'm gonna check my parent function. I mean, it won't check, it just checks first and it just prints that. Okay, if I remove this walk function from here and I run it, it's gonna call the parent function because the child function doesn't have any function known as walk. Then it will call the function walk function from parent class, or functional methods are same. Okay, so if I use functional method, both are same. So if I write this, okay, so this is as the same name. Are you guys remembering something? Same name of method. Over here also, same name. I showed you something, same name, which is known as method overloading, right? But when you write a method, when you write a same method inside a child class, okay, so this is the method, walk method, which is also there in the uh, parent class, right? And if you're writing the same method, that is known as method overriding. Okay, so you can see there's some arrow over here. So it says overrides Java basics dot robot dot walk. Okay, so I'm overriding this function. So the best practice is to write annotation like override. So I'm overriding this function which is there in the parent class. Okay, similarly, I can override more methods which are there inside the parent class, and this is known as method overriding, and this is referred to as runtime polymorphism, and it is also known as late binding. Runtime, why it is runtime? Because when you're calling from parent, okay, if we talk about parent class, when we use parent classes object and call the walk method, it knows in the compile time, yes, okay, we'll have to call the walk function only because there is only one function, one walk function. But when we talk about this child class, and this has the same method which is there in the parent class, so in the it will know in the compile time which method it will call, but in the runtime it will know that okay, if I have method, the same method inside my child class, I'm gonna override it and run that method. If not, I'm gonna go to the parent class and then I'm gonna run that method. Okay, so that's why it's known as runtime polymorphism. And actually, poly means many, okay, and form of morphism means forms. So that means many forms. Okay, so methods are there in many forms, like different, you know, same name but with different signatures, return types, or different arguments, like I've already showed. Now we had this keyword for the same class. Now, if you want to call the constructor, similarly, if you want to call the constructor or the method or the field name from the child class, so you will have to use super keyword. Okay, so let me create a constructor for my fighter class. So how to create the constructor? Same as the class name, parenthesis, and this is my constructor for my fighter class. Okay, now if I call super, okay, if I simply call this, that means I'm gonna call my constructor, right? So constructor of which class? Constructor of my parent class. Okay, right. Now using this super keyword, so I'm already calling my constructor, but using this super keyword, I'm actually can call another constructor also. Like if I pass it a name and if I pass it a chip number, let's just say 2010. Okay, so now it's gonna call the constructor which catches these values, which catches these arguments, right? So which is this one, right? If I run it, see, it gave me this name, RN, and everything. And because this is the child class, and obviously it's gonna call the parent class's constructor. Okay, so super keyword to call the immediate parent class object. Okay, now similarly, there is any field inside the robot class. Let's just say that we have a one more field known as model number. For example, let's just say it is some 4444, and if I want to access this from my child class, I can use super keyword again. So super dot the model number. See, everything is coming, steps, name, model number. So I'm gonna select my model number, and if I run it, so it's gonna print my model number also, right? Let me comment these two, and I can call the method also from this super. So is there any method? Yes, we have a walk function, right? So we can call the walk function, using the super keyword, right? So if I run it, see, so it called robot is walking, which is there inside the parent class. So this was about super. So in this, we used to call the uh, classes, field names, or sorry, constructor, field names, or methods from the same class. And using super, we call the same, methods, constructor, and field names of the parent class. Okay. So there's one more catch. So I mean, this is it for the session, but I would like to tell you one more thing that you can create one more class, right? You can create, let's just say, a dancer robot. Okay. So I can extend this. Okay, this can extend robot class. Okay. So I can create as many as classes I want, and I can use the extend keyword. Okay. But here is one catch that I cannot extend more than one class. Okay, I cannot extend my dancer class also. This is not there in Java. Okay, Java does not support this, but Java support one more thing which is known as interfaces. Okay, that we'll learn in the next session. So yeah, this was it for the session. Thank you very much for joining, and we'll meet in the next video.